Discover why your best ideas come when you're not trying, and understand the fascinating neuroscience behind creative breakthroughs. Creative insight is a mysterious process where ideas seem to pop into existence when we least expect them. The paradox is simple. Focused attention helps us work, but creative breakthroughs happen when we relax and let our minds wander. Your brain has two competing networks that control how you think. The executive control network is like a spotlight. It helps you focus on specific tasks, solve known problems, and execute plans. The default mode network turns on when you're daydreaming, showering, or walking. This is when your brain makes unexpected connections. These two networks usually work against each other. When one is active, the other is suppressed. Think of them as a seesaw. Brain imaging shows an inverse relationship. When executive control increases, default mode decreases, and vice versa. You might wonder, why can't both networks work together? Why do they compete? The answer is energy. Your brain uses about 20% of your body's energy, despite being only 2% of body weight. It must choose where to allocate resources. Let's dive deeper into the default mode network, the star of creative insight. The default mode network was discovered by accident. Scientists noticed certain brain regions became more active when people weren't doing any task at all. The DMN includes key regions: the posterior cingulate cortex, medial prefrontal cortex, and inferior parietal lobule. These areas light up together during rest. What does the DMN do? It retrieves memories, imagines future scenarios, thinks about other people's thoughts, and reflects on your own identity. Neuroscientists measure DMN activity by calculating how synchronized signals are across these brain regions during rest periods. Now let's understand exactly how the DMN generates creative insights. Creativity isn't about generating new information. It's about connecting existing ideas in novel ways. Focused thinking connects nearby ideas. Creative insight connects distant, seemingly unrelated concepts. The DMN excels at making these long-range connections. Think of Archimedes discovering water displacement while bathing. The problem of measuring volume connected with the observation of rising water levels. Research shows creativity correlates with DMN activity, multiplied by semantic distance between connected concepts. The further apart the ideas, the more creative the insight. Let's explore the neuroscience behind why showers and walks spark creativity. When you focus intensely on a problem, your executive control network searches a narrow space of obvious solutions. You look where the light is brightest. Focused search is systematic but limited. You examine the logical paths, but creative solutions often lie outside this narrow beam. When you relax and the DMN activates, your brain's search expands dramatically. Random associations become possible. Distant memories surface. The DMN creates a spreading activation pattern, where one thought triggers another, then another, exploring vast conceptual territory effortlessly. Studies estimate the DMN explores roughly 5 times more conceptual space than focused attention, though the search is less systematic. Now we'll examine the incubation effect, a well-documented phenomenon in creativity research. Hundreds of studies confirm that taking breaks from difficult problems improves solution rates by 20 to 40%. What exactly happens in your brain during these breaks? Why does stepping away help? The answer is unconscious processing. Your default mode network continues exploring the problem space without your awareness, making connections you couldn't see while focused. The optimal incubation period is typically 30 to 60 minutes, long enough for DMN processing, short enough that you don't forget the problem context. Meta-analyses show baseline insight probability of 15% increases by 25% with proper incubation periods. Different brainwave frequencies are associated with different types of thinking. Beta waves, oscillating at 13 to 30 Hz, dominate when you're focused and alert. This is your executive control network at work. Alpha waves, at 8 to 12 Hz, increase during relaxation. These are strongly associated with creative insight moments. Beta waves have high frequency and low amplitude. Alpha waves are slower and more rhythmic, creating the mental state for insight. Neuroscientists measure alpha power by taking the fast Fourier transform of EEG signals and integrating over the 8 to 12 Hz frequency band. Remarkably, researchers can detect an alpha wave burst in the right temporal lobe exactly 1 second before people report having an insight. How can we use this knowledge to enhance our creativity in daily life? First, deliberately schedule breaks when working on challenging problems. Don't power through. Give your DMN time to work. Second, during breaks, choose activities that don't demand much attention. Walking, showering, doodling, or gentle exercise. Activities like walking, showering, doodling, and gardening are ideal. They occupy your hands but free your mind. Avoid checking email or social media during breaks. These activate your executive control network and suppress the DMN, defeating the purpose. Always keep a notebook handy. Insights are fleeting. Write them down immediately or they'll vanish like dreams upon waking. Why are showers particularly effective for creative insights? Showers offer mild, pleasant sensory stimulation, warm water, white noise, and rhythmic patterns. This is enough to prevent boredom, but not enough to demand attention. Warm water triggers dopamine release, the neurotransmitter associated with reward and motivation. This enhances creative thinking. The shower creates an isolated environment free from interruptions, with just enough sensory input to keep the DMN active without distractions. Studies show dopamine levels during warm showers increase to approximately 1.5 times baseline, an optimal level for creative cognition. The default mode network isn't always beneficial. Let's examine its dark side. Excessive default mode network activity is associated with depression, anxiety, and rumination. Too much mind wandering can be harmful. Rumination is when the DMN gets stuck in negative thought loops, repeatedly cycling through problems without reaching solutions. Rumination is a closed loop of negative thoughts. Unlike creative insight, which opens new pathways, rumination circles endlessly without progress. Meditation and mindfulness practices help regulate default mode network activity, reducing harmful rumination while preserving beneficial mind wandering. The goal is optimal DMN activity, total mind wandering minus rumination. Quality matters more than quantity. Recent research suggests the best creativity comes from switching between networks. The latest findings show that neither constant focus nor constant relaxation produces maximum creativity. The sweet spot is switching between them. The optimal pattern alternates between focused work periods and relaxed incubation. This cycling allows both networks to contribute. Focused attention identifies the problem, gathers information, and primes relevant concepts. Then the DMN connects these primed concepts in novel ways. Computational models suggest creativity is proportional to focus time, multiplied by incubation time, raised to the power of 0.7. How do scientists objectively measure that aha moment of creative insight? The remote associates test asks you to find a word connecting 3 seemingly unrelated words. For example, cottage, Swiss, and cake all connect to cheese. This test reliably distinguishes between analytical solving, where you methodically test words, and insight solving, where the answer suddenly appears. Brain imaging detects distinct neural signatures 1 to 2 seconds before people report conscious insight, including alpha bursts and gamma synchronization. Interestingly, the neural signature of insight precedes conscious awareness by about 300 milliseconds. Your brain knows before you do. Various neurotransmitters modulate the balance between focused and creative thinking. Dopamine, often called the creativity molecule, enhances flexible thinking and helps detect novel patterns in seemingly random information. Norepinephrine increases during focused attention and stress, sharpening your concentration but potentially narrowing your associative scope. 4 key neurotransmitters modulate creativity: dopamine for flexibility, serotonin for mood, norepinephrine for focus, and acetylcholine for attention. A simplified model suggests creativity is proportional to dopamine divided by the square root of norepinephrine, balancing flexibility with focus. Sleep provides another window into how the brain consolidates creative insights. During REM sleep, brain activation patterns resemble the default mode network during waking rest, suggesting similar associative processes occur. Dream content frequently involves bizarre combinations of recent experiences and older memories, the same associative mixing that generates creative insights. Sleep cycles alternate between NREM, which consolidates memories, and REM, which makes creative associations. Both contribute to problem solving. Studies show that sleeping on a problem increases solution rates by approximately 33% compared to equivalent waking time. The probability of solving an insight problem after sleep is 1.3, 3 times the probability after an equal period awake. Not everyone's default mode network functions identically, leading to different creative styles. People with higher baseline DMN connectivity tend to score higher on divergent thinking tests, generating more unique ideas in brainstorming. This raises an interesting question. Are creative people born with different brains, or do their brains develop differently through practice? The answer is both. Genetics establish baseline DMN connectivity, but training and experience can modify these networks throughout life. While genetics play a role, deliberate practice and learning can strengthen the DMN, enhancing creative potential.